So let's look at a couple application type problems for quadratic equations. Here we have a rainwater collection system for a roof. That's what we're trying to find. And we know our house is 50 foot by 34 feet. So you can think of the house like this. It's a peaked roof, which means it's going to look like this. Very basic kind of idea. And we have a foot overhang all around. So that's the reason why I created the roof going further past it. So this is going to be 50 by 34. So this is 50 feet on that side and 34 on this side. And we know that we have an average rainfall of 50 inches per year. So we're asking how many gallons of rainwater should we expect? Because then we would want, a tank that can contain a certain number of gallons. Maybe you'll use them up and whatever, but you have to know how much you get per year so that you can figure that out. Well, there's a formula for this. The rainwater in gallons is going to be the area of the roof times the amount of rain you get. And the amount of rain you get really is a height measurement. So it's like, how tall, if you're just have like a column of water, how tall it would go up with over 1 year. And the area measurement times the height measurement, that is a volume. Volume, of course, can be written as a with a conversion as a liquid capacity, because a liquid capacity is also a volume. And that is what the 187 over 300 does, is it just changes 50 feet squared times inches into gallons. So we already know the amount of rain, that's 50 inches. Now all we have to do is figure out what is the surface area of the roof that we have in our house. Well, if it's a 1 inch overhang, that's what it says here, or sorry, a 1 foot overhang all the way around, then really we don't have a 54 or 50 by 34. It's going to be a 52 feet by 36 feet this way, as a pretty decent approximation. And so what we want to do is we don't want to multiply 36 by 52, because that would give us just the area of this flat, rectangle. But we have a peaked roof, so we actually need to figure out what's the area of this portion, and then the same thing on the other side is actually the same thing, so just multiply it by 2. Well, to do that, we have to understand what is the slant side there. So let's go ahead and look down the house like this, just going straight down the house. Because this is a peaked roof, we can assume that's directly halfway between the two sides. And this was 36. Each portion is 18 feet. And the fact that we have a the pitch is 4 feet to 12 feet. That means as we go 12 feet in, we go 4 feet up. So here we're going 18 feet in. That means we're not going to go 4 feet, but 6 feet up, because 12 can go to 18 1.5 times. So 4 times 1.5 is 6. So this is 6 feet tall. And we're trying to figure out what is this distance here. By the Pythagorean theorem, we can see that's going to be 18 squared plus 6 squared equals x squared. This is a quadratic equation. So all we really have to do here is just take a square root of both sides. And whenever you take a square root, you have to add in a plus or minus in front of it. Okay, let's grab a calculator. 18 squared is 324 plus 36, which is 6 squared. And then taking the square root of that gives us 18.97 approximately. And because we're looking at a distance measurement here, we actually don't need the negative. Distances cannot be negative, so there's no real reason to use or leave the negative in there. So x is just equal to 18.97. And now we can find the surface area of this. So we have 18.97 is the side measurement. And we have 52 feet long, and there's 2 of them. So really the area for the roof is going to be 52 times 18.97 times 2. And that will give us 1972.88 approximately. Well, that would be exact if we use exactly 8.97, but that's approximately the area. And now all we have to do is plug it into our formula and find the rainwater in gallons. So the rainwater is going to equal the area, which is in feet squared, right? This is a foot. This is a foot measurement, so we have feet times feet is feet squared, times 50 inches of rainwater per year, times the unit conversion to gallons. And plugging that into a calculator, it's going to give us approximately 61,488 gallons of water. Of course, we've already done some estimations, so you really could say this is just about 60,000 gallons, but that is the process for that one. All right, say you want to build a room with an indoor pool, and you know you want the room to be 700 feet squared, and we want a uniform walkway for the aesthetics purposes all the way around the pool. So the uniform walkway means it's just the same width all the way around. Now, looking online, you can find out that a decent sized pool is 18 by 36 feet. So with these dimensions, what size walkway fits in the room? Well, we know it's going to be 700 feet squared, and 18 by 36 feet is a certain square footage. And we got to figure out how much is the walkway. So whenever possible, always draw a picture because it's going to make the mathematics a little bit easier to see. So 18 by 36 is really twice as long as it is wide. And then on top of that, I'm actually going to write this on the inside here. 18 by 36. And on top of that, we're going to have a uniform walkway. That just means it's the same width all the way around. And we don't know what that width is, but we are trying to figure out what is that width. So let's make that our variable x. Of course, if that's x, this is also x. So is this, and so is this. Now, this is important because the square footage of this room is length times width. This is our length. This is our width. Our length is going to be everything all the way across. So we're going to have x plus 36 plus x. Or in other words, 2x plus 36. Along a similar line of reasoning, we have our height is going to be x plus 18 plus x going down. So our width or height, same difference. That's going to be x plus 18 plus x, or 2x plus 18. And so our total area of this thing is going to be length times width. Is length times the width. And we know our area has to be 700 square feet. I can get rid of the a. And this is just a quadratic equation that we can solve by, in this case, we're going to distribute everything on the left-hand side. So let's go ahead and do that. We're going to get 4x squared plus 36x plus 72x. And let's see, 36 times 18, 648. Let's subtract 700 over. That's going to give me 108x minus 52. and we want to factor this. So first off, I want to see if I can divide everything by 4. 52 can, I believe. Yes. So we're going to get x squared plus 27x plus or minus 13 equals 0. I just divided everything by 4. And now I can try and factor this thing out. It's not going to work because 13 is 13 times 1. And no way does that give us 27. So really I'm going to have to use the quadratic formula. So let's go ahead and do that. A is 1, B is 27, and C is negative 13. So we have negative B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. And simplifying this down, let's figure out what is the discriminant. 27 squared minus 4 times, plus 4 times 13, 781. And I'm going to go ahead and calculate the two numbers since we're trying to figure out what is the actual number here. So we're going to have negative 27 plus the square root of 781 divided by 2. That gives us 0.473. And then doing the same thing, negative 27 minus the square root of 781 divided by 2. And this one we can really just throw out because this is a negative number. And then once again, the distance cannot be negative, so that's not possible. And what we find is that the only way that this works is if we have a walkway, a uniform walkway of 0.473, and the unit of measurement here is feet because we use feet here and feet here. So would you be able to have, about half a foot walkway all the way around the pool? No, that's way too small to walk on. So really what this tells you is that you have to either increase the dimensions of the room or decrease the dimensions of the pool, else you're not going to have room enough to walk around. All right, next we're going to look at an arrow's height versus time that's being shot with an angle of 45 degrees at a speed of 150 feet per second and a starting height of 6 feet. This can be modeled with this equation, so we don't actually have to make the equation. It's just given to us. And the question is, how long does the arrow take to hit the ground? And if its horizontal speed is 106 feet per second, how far did it go? So we're assuming no air resistance, which means there's nothing pushing against the arrow. It's going to go exactly with that speed, so 106 feet per second. But before we can do that, we have to ask how long is the arrow in the air for, because that will give us a time. And we can use this equation, right? This equation equals 0 when the arrow hits the ground. So really what we're asking here is, when is it equal to 0? So 6 plus 106t minus 16t squared. This equation actually comes from the kinematic equation in physics. It's pretty easy to derive once you know how to work with those. This is just a quadratic equation. We can solve it using the normal methods. I'm going to go ahead and divide by at least 2. Yeah, I have to divide by 2. That gives me 3 plus 53t minus 8t squared. And I can try factoring this. I don't imagine it'll work. So I want to go ahead and use the quadratic formula. So I don't have it written the normal way. I can just rewrite it as negative 8t squared plus 53t plus 3 equals 0. And now I have my A, B, and C. So t equals negative b plus or minus b squared minus 4 times a times c all over 2 times a. Okay, this is going to give us, we figure out what is the discriminant. 53 squared plus 4 times 8 times 3. It's going to give us the square root of 2905, negative 16. All right, going back, we're going to get negative 53 plus or minus approximately 53.898 over negative 16. And when you're looking at this, there's no reason to use the positive version because we're looking for only positive values of t. It doesn't make sense to have negative t here because that would be back in time, which you can't do. So we're only looking for positive values. And the only way that's going to be positive is if we ignore the plus value on top here. Negative minus a negative is negative, divided by a negative is positive. If I were to plug the positive value in here, I would have a very small positive number on top, divided by a negative number. That would have given me a negative. So there's no need to check the negative, or sorry, the plus version. Going ahead and doing the negative version, we're going to get 106.898 divided by 16. That's going to give us 6.68 seconds in the air. It's going to be seconds because our unit of measurements was feet per second here for the speed. So we have seconds for the time. Now, it's in the air for 6.68 seconds. And if it's in the air for that long, that means it's traveling horizontally with this speed, 106 feet per second. So its distance, its actual horizontal distance that it travels is going to be the speed that it goes times the time that it does that speed. Right? This is going to be feet per second times second. The seconds cancel. And we get 106 times 6.68. It travels 708.08 feet. Quite a far distance. All right, try it out in numbers 3, 4, 5, and 6.